snapper stories at a later date. So those are good ones. All right, so homework assignment was we're doing the new algorithm thingy, right? Okay, so why don't we start a new project for that guy. Start a new Android Studio project. And we'll call this guy Shunting Yard Android. Actually, let's call it Shunting Yard. When we put it up on our, actually I'm going to call it Shunting Yard Android. That way when we put it up on GitHub, it will have the right a name that we can follow. I'll go ahead and say next. Phone and tablet, whatever. And we'll start with a empty activity. Why is this taking up so much of the screen? Yeah, I'm happier now. And we'll start off with our main activity and generate a layout file. I wonder why my fan is cranking here. This laptop usually doesn't go crazy like that. Chill off a couple of things here. We still have our node server running from last night. Do we? No? Eclipse. I don't know. Maybe it's just about time for a reboot. All right. Okay, so let's go ahead and let's create our, just as a reminder, we have a couple of different stacks and stuff here that we're working with, right? So let's open up our Keynote, and we'll also go to our Shunting Yard. So we're going to have a single text box, which takes in a postfix formatted string like this. We're going to use the Shunting Yard algorithm to convert the string into I wonder what that into. So this should actually be prefix order, right? It should support all these guys. Output example should be this. Okay, so we're not actually doing the math for the assignment. We're just doing the initial conversion. So we type in this, we should get this. So in order to do this, we're going to need a text box and a label for our output, right? Good enough. You know, you didn't have to use the label. You could have done in a log, but I think we'll do a label for this one. So we'll go ahead and go into our resources, go into our layout, go into our activity main. All right, we have this guy, and of course it still starts you out with a relative layout. I have no idea why, but whatever. So we already have a text view there. So I'm going to move let's stretch this guy out. Oh, nice. All right, and then let's go ahead and get our edit text. So this guy, we'll put him above there. And just for the sake of my own sanity, I'm going to create a vertical linear layout. We'll put that guy in there. We'll go ahead and throw the text view in there. And we'll throw the edit text in there. And we'll reorder those guys like that. And this guy should be vertical. And let's go ahead and stretch this out. All right. And we're going to have set some gravity for this dude. So let's center, well, we'll fill horizontally. I think that should get everything to stretch out. And then we'll center horizontally. So I guess with that in mind, it shouldn't necessarily matter. It shouldn't. All right, and let's go into our text here. And we're going to take our linear layout. We're going to cut that out of there. And we're going to replace our relative layout with that. Something wasn't happy there. Put these guys in there. And we'll steal this tools thing. Then we'll let me do something here. I'm just going to steal all of this. We'll just replace all of this with that. And then we should be able to do this now. And get rid of relative layout. Okay, and the world seems like it feels better at this point. Go back to our design. Which is funny. So if this is a orientation is going to be vertical. Okay, so there's that. And then gravity is going to be, oh, we don't want that center. We want center horizontal. Okay. And then we want fill horizontal. We should be able to stretch that guy all the way across. Stretch this guy all the way across. Oh. Actually, can't we just do this? We just tell these guys to fill their parent. Layout with, fill parent. Layout with, fill parent. Now, what's interesting here is why is that guy like that? Oh, it's got something coming off there. I wonder why that is. Let's just do this. We'll put a new plain text field in here. Alright, that looks a little bit better. This has been something I Okay. And then we can set this guy's gravity to be centered. And this guy's gravity to be centered. And we should have a relatively centered thing now. So let's give these guys some IDs. Just double click on this guy. We're going to call this guy output text. Output here. And then we're going to call him, let me actually make this guy a little taller. And we'll call this guy input TF. And I think we can, isn't there a placeholder thing we can give these guys? Postfix string. All right. Fair enough. All right, so we're going to give ourselves programmatic access to both of these guys inside of our main activity. Oh, we have that right up here. So let's go ahead and we'll say private input TF. This guy is going to be a, what is it, an edit text. Control, just option enter. There we go. And then this guy is going to be a label called output text. I don't know. Is it a text view, not a label? Let's look. I think the labels in this language. No, you're right. Edit text, text to you. All right, so we have those two guys, and then let's go ahead and hook them up. So we'll say this dot edit. I'm sorry, this dot input TF is equal to the edit text version of this dot find view by ID r dot ID dot input TF, and this dot output text is equal to the text view version of this dot find view by ID r dot ID dot output text. See? Same thing as doing a control drag, right? This has actually some of its benefits, doesn't it? Because with the control drag you would have had on the iPhone, you would have had to click the view controller and click the two circles and get the things lined up and drag and stuff when you just do it here. Almost this is faster in some ways. Okay, so now we have access to those guys, and let's just prove it real quick. We'll go ahead and say this dot the input TF dot set text equal to blah, and this dot output text dot set text equal to LOL. And let's just make sure everything is running right. So we'll go ahead and run it in our, do we already have one launched? That's interesting. It says offline. What happens if I run that? Is this a new version thing? Or it's able to resurrect an existing yeah, it's not. I wonder why it thinks that guy is there. So we'll go ahead and launch a new emulator. Oh, that's very cute. I don't know what the purpose of that is. Okay, so there's our evidence that it is working. Probably also want to throw a button on there that we can click to actually make the thing do its thing. So let's go ahead and throw our button in here. We're going to say, call that Shunting Yard. And we'll call this guy Convert Button. And then let's give ourselves access to that button. Actually, we don't need access to the button. We just need a public, void shunting yard button pressed. It's at UV. All right. And this is what we want to set that guy's on click to. All right. And let's make sure that guy is hooked up okay. So let's take this and we'll put that in here so that when we click the button it says LOL. All right, everything's all connected up. So now let's go ahead and create our shunting yard object. So we'll come in here, we're going to create a new Java class. We'll call this guy shunting yard. Okay. And again, in our shunting yard, let's open up shunting yard algorithm in Wikipedia. So we have a output queue. We have an input, I guess queue. We're always feeding off the front of it. So these are both queues. And then we have an operator stack, right? All right, so is there a queue in Java? Might be. Java.sun.com. Yeah, I think there is a queue. It's NQ and DQ is the, now I want a blizzard. I think it's in java.util. Yep, queue. Add, remove. Well, here, let's just go down to the normal method summary. So this queue also do so immediately without violating capacity restrictions. Okay. From the head of the queue. Okay. I might as well use a queue. Seems very Java-esque. So we'll go ahead and we'll create our couple of guys in here that are, so we're going to have a private, make sure it matches our stuff over here. So we'll call it output queue, input queue. So private queue. And this is going to be a queue of strings called output queue. And this is going to be equal to a new queue of strings. Row. What the heck? Just creating a variable. Oh, it's abstract. We can't create a instance of that. Well, that seems completely sub-interfaces, implementing classes. Well, guess we're just going to have to use a linked list. They don't give us a generic queue. We'll still call it output queue. All right, so we're going to create a linked list of string called output queue, and this is going to be a new linked list of strings. We'll have a private linked list of string input queue, and this is going to be a new linked list of string, like that. And then we're going to have a private stack of strings called opqueue, and this is our op stack. And this will be a new stack of strings. And that guy should allow it. Okay, so these are our dudes. Now, in order for shunting yard to work, we're going to need our initial input string of our postfix format, right? Okay, so we're going to go ahead and we're going to create our constructor. So public shunting yard. This guy will take a string postfix as a parameter, and we need to go ahead and split this string up and throw it into our input queue in order, right? All right, so we talked about a couple of ways we can split this up. Probably the most, probably the best way for us to split it here is going to be the string tokenizer, because that allows us to give it all of the individual tokens we want to split on, and also tell it that we want to keep the tokens. All right, so we're going to go ahead and say we're going to create a string tokenizer. ST is equal to a new string tokenizer. All right, and this guy is going to take in, whoop, I don't get to choose the constructor, I just have to, okay, well, whatever. So the string we're going to pass this guy as postfix, and then we're going to pass it the actual operators, or the things we're tokenizing on, and we should support plus minus times divide power open close parenthesis. All right, and then true, we wanted to return the actual delimiters, right? Okay. And just in case somebody sends us white space, we're going to want to go ahead and probably trim every string we get from that. So if we had a string that looked like a 123, but it actually had a space after that, if we call trim on that string, it'll take that space out. Okay. Otherwise, you can just assume they put the thing in without spaces. That's fine as well. But we'll make ours here a little bit more robust. So we're going to say while st.has more elements, has more tokens, same thing, but I like to use the has more tokens for no good reason. I would say it's because it's what my fingers are used to typing, but clearly that wasn't the case. All right. So we're going to go through here, and for each token, so like if we had 123 plus 75, we're going to take the 123 and we're going to add it to the end of our queue, We keep adding each of our tokens to the end, leaving ourselves a list. Right? So if we came in here and we split it up this way, we're going to treat this guy like a queue. And so we would split these up into these components, and we'll add the A first, then to the end, add the plus to the end of that, the B to the end of that, the times to the end of that, so on and so forth. So we'll treat these guys like queues, even though we technically have a linked list. So we're going to go ahead and say this dot input queue dot add. Where's this guy? Put it? Yeah, we'll do add last. And what are we adding to last? Some string. What string? st.nextToken.trim. That should put it into our linked list there. And we'll keep doing that as long as there are more tokens inside of our tokenizer. All right, and then for right now, let's go ahead and give ourselves a function called that returns a string. Let's just call it getAnswer for right now. And let's have this guy return our linked list as a as a string. So let's just say string answer is equal to the empty string, and actually let me check something here. It has a toString, but I wonder what that ends up looking like, because it's probably the default one. I think it'll show us the object version of that, so it'll look like so we'll say for string part in this dot input queue, we'll say answer plus equals part concatenated with, we'll draw a little arrow kind of showing it's a linked list. We'll have an extra arrow on the end, and then we'll go ahead and return answer. So that's going to be our get answer, and let's just make sure that we're getting everything loaded into our input queue properly. So we'll test this. So go into our main activity. When we press the shunting yard button, we're going to go ahead and create an instance of shunting yard. And this guy's going to be a new shunting yard, passing it a string. What string? This dot input tf dot get text dot toString. Okay, and then we'll go ahead and say this dot output text dot set text, and we'll set it to sy.getAnswer. They should look the same, but there should be some arrows in there proving that hopefully things got put in the right order and that we got the individual tokens, we got the individual pieces. So let's go ahead and run this again. I don't know why this is cooking here for a second. For those of you who have not already done so, I'd encourage all of you to sign up for the hackathon on Saturday morning. It's downtown Milwaukee. We'll be figuring out transportation leaving campus if you want to ride. From 9 a.m. to 5 p.m. comes with free food, and we're going to be organizing groups from Concordia. Basically, you'll work in a team of 2 or 3 people to create some project for the day, but a good experience of creating a project from beginning to end-ish, let's say. And it'd be fun and good experience and get to see other developers do things. Doesn't matter how good you perceive your skills are, we'll put you with some seniors and stuff, so it's supposed to be a learning experience, not something where you don't feel like you'd be a great contributor. That doesn't matter. I think it's a good experience, and a lot of our students who have gone to the various hackathons we do tend to get pretty good developer jobs and tend to learn a lot more than you typically would even learn in a semester. Yeah, but
For people that are going to the event, would you give them a pass on the homework creation?
well,
Is that
Yeah, I could do that. I think that sounds like a fair trade.
Doesn't
It does. Yeah, I think I can. I think I can swing that. Okay. But the people who don't sign up for it should get impossible homework over the weekend.
That's totally up to you.
So you don't want to torture your classmates because this will be on you at the end.
No.
So if I don't give you homework over the weekend, how many would go to the hackathon? It's 9 a.m. until 5 p.m. on Saturday. Usually hackathons are 24-hour events, so this is a much smaller thing. You get breakfast, you get lunch, and I don't know if you get dinner or not, but it's just a cool experience. It's in a space down a town called the Commons, which is like a incubator startup space. So companies pay for like a seat in that place to basically have a startup company where they're not having to pay for office space and stuff like that, but they have a place where people can come in for meetings. So it's a really cool, I guess, workspace. So you get to kind of see how startup communities, startup companies kind of start. We're actually going to be building something like the Commons here on campus in our new business school. The computer science department's partnering with the business department for building this incubator type thing. But, it'll be a cool experience, I think. And, if you can only come for part of the day, that's fine too. But I would say if you're going to do that, meet us there instead of, we're not going to do bus trips back and forth. But, if you like to come for 2 or 3 hours just to get a feel for it, it's fine. But if you're going to do it, go on to, there's a link on in most of the chat windows, but on Slack, I think the original link is in general chat. You have to sign up for the event. It doesn't cost anything. Just make sure you sign up and then let me know so I can add you to the list because I'm creating groups that are kind of well-formed groups, I guess. And if you don't plan on staying the whole day, let me know so I can maybe put you in a group that either, is a group of people who aren't staying the whole day or something like that. Just let me know so I can take that into consideration. But it is a good experience and would be well worth your time from a learning perspective. Out of curiosity, how many people in here are planning on going to this thing? 1.5-ish? All right, well, 1 3/4? With a lock-in, maybe for? Yeah. So? Just stay up a little longer. They have free food and caffeine and stuff. Huh? Yeah, it's free. You can sleep later. Plus, you're going to have that death homework assignment. It'll take way more than 2 or 3 days. It'll be like a week-long assignment. Yeah, because I'm pretty sure the next assignment we're going to do deals with pattern recognition stuff. It's another algorithm I like doing next. So it's going to be nuts. Yeah, it's worse than that. So take what you think is scary and then like triple that and then have blood dripping off of it. General chat. Yeah, so why don't you scroll up? Yeah, it says technology these days. Wow. Yeah, I think it'd be a good experience. I'll tell you what, I've had students, like last year when we went to Raleigh, I mean, we had students that were basically beginning programmers, drove 14 hours with us to Raleigh for a hackathon, and, we're kind of a weak link on the team they were on, but the very next hackathon they did in Chicago, they were like team leaders. And the amount you learn in that period of time, I mean, it's not a 24-hour one. This one's a small mini one, but it's huge because you're doing things that aren't like normal classroom stuff. You're integrating APIs and you're creating a product that's talking to third-party stuff. You might bring in Google Maps and just different types of exterior data, which is things that we typically don't do in class because in class we're looking at theory-based stuff, kind of building blocks that you might use in future software development rather than maybe more practical stuff that would translate directly to what you might actually be doing in the real world. So kind of two different sides of the coin, I guess. Okay, so let's go ahead and put a string in here. So we'll do 123 plus 8 divided by 5 times, oh, why is that key not working? Oh, there we go. Times 2 plus 1 to the, whatever, 4th power. Waste of time, but whatever. All right, so we got some spaces in here. We got some non-spaces, and go ahead and run shunting yard. So there's a 123, which links to a plus, which links to an 8, which links to a divide, which links to a 5, a times, a 2, a plus, a parenthesis, a 1, a power, a 4, a close parenthesis, and then, like I said, we have an extra little arrow at the end there. All right, so does it look like we're loading our input Q accurately? Okay, so we have that guy. Now, we go back into here. One thing we have to deal with is in ours, we need to treat our power as kind of a special case, right? So you can either create this little chart, so we know from the powers of these guys, and then we also have to take a second step and know that when something is right associative, the rules change a little bit for it. All right, so we'll burn that bridge when we get there. So we're going to go ahead and in our code, we're going to create this chart of powers. So inside of shunting yard, let's go ahead and just give ourselves a function, private int op priority. And this guy will take in a string op as a parameter. Okay, let's say, probably better off just doing an if statement for this. So we'll say if op dot equals a plus sign or op dot equals a minus sign, return 2, else if it's times or divide, return 3, else we're going to have it return 4. All right, so now what do we do with parentheses? An opening parenthesis. We treat those as special cases. We always put an opening parenthesis on top of our operators. There's no popping associated with it. We only do popping when we hit that closing parenthesis and we know we need to kind of clear out the op stack, right? All right, so we're probably not going to send those guys to our op priority because we're going to have to check to see if it's not one of those first. Otherwise, we'll get our op priority to see if we're allowed to do this stuff. Okay, now keep in mind that we're doing this a little bit special purpose for our type of equation since technically shunting yard allows for things like sine and cosine and things like that. So this would probably get a little bit more complicated, but we'll just leave it like this for ours and say that that's good enough. Okay, so let's go ahead and that's our op priority. So when we say get answer, what we're effectively saying is let's start processing our queue, right? All right, so let's get rid of this for right now. Here, I'll just put a empty string here at the bottom so it's not complaining at us in the meantime. So we want to continue to process our input stack as long as there's stuff there. So while there are still things inside our input queue. So while there are still things inside of our input queue, we need to do things. All right, so we'll do while this dot input queue dot, we have a dot size is greater than 0. As long as there's stuff in there, we're going to go ahead and remove the first thing and decide what we're going to do with it, right? Every single time through, we always remove from the input stack or in the input queue, and then we either put it in the output queue or put it in the output or the op stack. So we'll create a little string called cur symbol. We'll go ahead and set cur symbol equal to this dot input queue dot remove first. Okay, because we removed from the front of that queue. So now we have a symbol that we need to decide what to do with this guy. Okay. First thing we need to figure out is this guy an op? So let's go ahead and create another function, Boolean is op, that's going to take in a string. Call this guy symbol, and this will return plus, minus, times, divide, dot index of symbol. We may not have looked at that before, but there's a version of index of that takes a string. Not just there's a version that takes a char. There's also a version that takes a string. So we'll call dot index of, passing it the symbol. If this guy is an op, the value it returns will be something greater than well, 0 or greater, right? If that guy is greater or equal to 0, that'll return true. Oh, thank you. All right, so we'll have this is our op string. We'll check for whatever symbol they pass in for the index of that symbol in this op string. If it gives us a position greater than or equal to 0, that means it was found in there and will return true because this guy is an op. Otherwise, it'll return false, not an op. Okay, so that's our ability to check for an op. All right, so if this dot is op, cur symbol, okay, then we need to potentially, so we have an op, what do we do with it? Well, ultimately it's going to end up on our op stack, right? But we, well, I suppose unless it's a one of the parenthesis dudes, it might not end up on there if it's a closing parenthesis. But, you know, more than likely it's ending up on our op stack, and we'll take it from there. So first thing we need to do is we need to determine if it's one of our parenthesis guys, right? So if cur symbol dot equals an opening parenthesis, we just immediately add it to our op stack, right? So then we'll say this dot op stack dot push cur symbol, right? So in the event that we are dealing with an open parenthesis, goes on the op stack, we don't need to check anything, blah, blah, blah. Okay. Else if cur symbol dot equals a closing parenthesis, we need to clear the op stack to the opening and add to output queue, right? All right, so what do? We continually check our op stack for, well, we keep popping elements off our op stack, checking each element until we finally hit an opening parenthesis. Once we hit the opening parenthesis, and we're going to assume that we have legal postfix things coming in, that is, that somebody didn't have an opening parenthesis without a matching closing parenthesis, so we're not going to error check it. So as long as we have, we technically don't even need to check to see if there's stuff still in our op stack, but we could say something like while this dot op stack dot size, we'll actually say, yeah, well, it's not empty, Let's see, two different empty things. It seems like a kind of a waste of time, doesn't it? I bet you one of them came from a different parent class. Like stack inherits from, I bet you one of them came from linked lists and the other one came from, I don't know, or maybe it came from stack. Now I'm interested. So let's look at stack. That dude has an empty and an is empty. Stack live. Oh, those are interfaces, not classes. So a stack is a vector, which is an abstract list, which is an abstract collection, which is an object. So down at the bottom, you can usually see where it got different stuff from. Yeah, methods inherited from vector is methods inherited from what? Oh, okay, so vector gave him is empty. Well, I don't think he had an empty himself. Oh, thank you. So empty tested the stack as empty is empty came from vector. I would think it would give us the same output, but if not, why would they have implemented empty? So we're using the correct one here. This is the one that stack specifically implemented to test if a stack is empty. So if this stack is not empty, we want to go ahead and pop something off the stack, decide whether or not we should add it to our output queue. So we're going to go ahead and give ourselves a curop. So we'll say curop is equal to this dot opstack dot pop. And we'll say if curop dot equals the opening parenthesis. We finally hit our opening parenthesis. We can break out of here, right? So we're done doing stuff. Else, we want to say this dot output queue dot add last curop. So we'll add the curop to our output queue. Opening parenthesis, throw it on the op stack. Closing parenthesis, burn through our op stack until we finally hit the matching opening parenthesis. Else if so we can handle, well, we can say else it must be an operator. Let's go that route. Must be a normal operator. So we need to now look at the current top of our stack because we need to effectively try to add this to the op stack over and over until it finally fits. All right. So we need to determine whether or not we're allowed to add this to the op stack. And under what conditions are we allowed to add this to the op stack? We're able to add it to the op stack if it's less than or equal to the guy at the top of the op stack, right? Go back in here. We were able to add the plus sign first. Multiplication, oh, it's got to be greater than, sorry. So multiplication, as long as it's greater than what's at the current top of the stack, because when we get to equal to, so yeah, it's got to be greater than, because equal to requires us to move it as well. But then we have the caveat of our the power, the caret. So the caret works differently. That guy does what? What's the rules for the... So, yeah, that allowed it to go on top of a divide. Yeah, so since it's right to left, we can just add it. So we don't even need to check its... Well, in our case here, we can just add it. Is that a correct statement? Because it's greater than everything, but it wouldn't necessarily... Like if we had sign there, I don't think we could just put it right on top of sign. But we can put it on top of itself, which is an equal to. So if sign was had a greater power than it, I don't think we'd have to pop it. We don't have that situation. So in our world, we can just add it. So then why don't we do this? We're going to say else if per symbol is equal to caret. So let's just finish up this part right here, and then we'll call it quits for the day in preparation for our giant assignment over the weekend. Then we'll go ahead and say this dot opstack dot push cur symbol. Okay. Else we need to do our processing. So we're going to start here for our homework. And I'll go ahead and import into version control, create Git share project on GitHub. Shunting yard algorithm, share, all that stuff. Always allow. Yes, should be up there now. Yep, there's our shunting yard. All right, I will see everybody on Thursday. Make sure you message me if you sign up for the hackathon so I can add you to the list.